All right, looks like we are live. Welcome, everybody, to Standing for Truth. I am your host, Donnie, and I want to thank you all for being here for today's much anticipated debate between Professor David McQueen and Luca Medugno. The question we are debating tonight has to do with the heat problem. Does a heat problem preclude a worldwide flood? A very important topic. Now, on this channel, we host debates, interviews, discussions, and more. So if you're not yet subscribed, please hit that subscribe button and share around this content, as the truth is important. We strongly believe on this channel in critical thinking, and this is exactly why a good amount of our content consists of debates and informal dialogue. A great way to determine truth is by engaging those of differing beliefs and views. And a way we promote this type of critical thinking is by hosting some really awesome debates, such as this one. Gentlemen, Professor David McQueen, Luca Medugno, thank you for giving us your time for this awesome debate.
Thank you, Donnie. I appreciate being here. Good to see you, Luca.
Good to see you both too. It's a pleasure to be here. It will be fun, this debate. I hope to do well and to put up a good fight. At least I want to try.
Before we begin, Donnie, with the very important argument between these two evolutionary versus biblical creation viewpoints, I wanted to compliment Luca for his ability to debate me as an Italian speaker, doing it in English and using the universal language of mathematics. It will be a good debate. I put myself in his shoes. What if I had to debate him in Italian? Before I even knew I was going to debate Luca, I've been studying Italian and have learned 20 words. Let me try my words out on Luca and see how they work. If you look over me here, you will see a Italian phrase that I hope, and I'm laughing when I say this, Luca, I'm hoping at the end of the debate you will say, Professore, hai ragione. Now, let's teach us what that means. That means...
Yes, the phrase is Professore hai ragione, and it means, Professor, you are right.
You are correct. And
yes,
then
correct,
when I don't understand Luca, I'm going to say the second phrase, Luca, mia capisci? Is that
Luca,
correct?
do you understand me?
Do you understand me? And for the American audience, I dressed up in my Godfather outfit here so that I can speak Italian with my hands and say okay and other complicated Italian phrases that we won't.
Okay, we will try. So I will love to. So, yeah,
and we will do it that way. So let me finish the lighthearted side and get ready for the argumentative side. Donnie, back over to you for the rules and so forth.
Well, I appreciate it, gentlemen. I enjoy the lightheartedness back and forth. I think we can all benefit from this. So, Luca, David, what I want to do, though, is kind of break the ice a little bit. You're both two well-studied individuals. Professor McQueen, you've worked years as a geologist. You're currently a retired geologist, still doing full-time research. Luca, from my understanding, you have a background in chemistry, physics, and you're working as a teacher. So why don't we kind of break the ice a little bit here, get to know the debaters before, as you gentlemen put it, we start bringing the heat. And the battle begins. So why don't we start with Luca? Luca, how you been? A little bit about yourself, and go ahead.
I'm mostly fine. I'm working as a teacher. We are closing in with the year, the school year. It's at its closure, so I did have a lot of work, but I did manage to put up, I think, a good argument for this debate, I hope. and I love to do these debates. It's very fun. I cannot wait to do this debate in particular. I really appreciate. I really appreciated the Professor McQueen in general. It was very nice to me. He's very polite, and I do love the fact he studied a little bit of Italian for me, so it was very kind. And that's all. Let's bring it up.
I appreciate the intro, Luca. This isn't your first rodeo. You've now had plenty of debates, and same with you, Professor McQueen. So you are both two seasoned and, as I put it earlier, well-studied individuals. So, Professor McQueen, how you been? What have you been up to? And a little bit about yourself, brother.
Oh, it's been a very good month in speaking to Luca about the mathematics of this heat problem. I have had the fun of going back to my textbooks from my university days at the University of Tennessee and the University of Michigan in the 1970s, looking back on physical chemistry, calculus, thermodynamics, and this whole heat problem in regard to the mathematics and the physics behind it, something that I'm looking forward to discussing. I, in my academic training, had 2 years of calculus. I've had several years of chemistry, including physical chemistry, which we're going to see comes into this argument when we talk about the creep of the mantle here in a few minutes. And so I'm so thankful that we can do English and Italian and the language of mathematics. Thank you, Donnie.
My pleasure. And again, thank you, gentlemen, for being here for such an important topic, a technical topic. And I, for one, am extremely excited for it, especially given the fact you both have prepared so greatly. So for the audience sake, let's go over the format. As usual here on this channel, it is going to be a professional, a formal debate. We are going to be having 15-minute opening statements. The title of the debate is, does a heat problem preclude a global flood? So Luca is in the affirmative. He would say yes to that. And David McQueen would say no. So Luca will be starting us off with a 15-minute opening statement. Then we're going to have a 10-minute uninterrupted rebuttal from each of the debaters, Luca and David. And then, guys, this is where we're going to have a 5-minute break. So we can refill our coffee mugs, bathroom break, so on and so forth. I will go over some reminders and announcements, as we do have a lot going on in terms of the ministry here. Then we're going to have a roughly 30-minute free-flowing discussion where Luca and David are taking turns asking each other questions pertaining to the topic of tonight's debate. Then a 5-minute concluding statement. And then this is where we get you guys in the audience involved. We're going to have an audience Q&A. Please make sure you're tagging me with your questions at Standing for Truth, and that way I won't miss them. Okay, why don't we get right into the fun, unless the debaters have any questions. We can kind of get right into it.
Yes.
I have my notebook, Luca, so I'm ready to take notes on what you say.
Good.
Luca, did you want me to give you a 1-minute warning, or are you planning on timing yourself? Whatever I can do to help you.
I will time myself, but if you want to give me a warning, don't worry about it. Okay.
Yeah, we can definitely share your screen as well, the both of you guys. Good to see everybody in the chat, by the way. I'm seeing some love and I think questions even coming in already. So yeah, tag me. I'll save them.
I'm ready.
Okay, here we go. Luca, your slides are up. You got 15 minutes. Looking forward to this.
Okay. Does the heat problem preclude a global flood? From me, of course. Here we can see the young Earth timeline, the pre-flood age, the flood, and the present time to from the flood to today, basically. And we will talk about this single here, of course. So, how much it we are talking about? Well, we can tell if the flood was a real event. I do not think so, but I will entertain this idea for this debate. During the flood, huge amount of it were produced. So we will look into some of those. Here you can see you all some of the sources. Plate tectonics, meteoritic impact, and that's a big one, but it will be it just to give a number. As nuclear decay, if we accelerated it, it's very, very huge amount of it, and something that we will touch in this presentation is the material from the mantle. So the young Earth part of this discussion has proposed some solution like heat sink, black body radiation, so still sink but in space, hypercanes, huge storms that will consume some of the heat, and the zeta pinch effect from the Proton 21 laboratory. We will talk about only a part of this solution, but I'm prepared to discuss on all of them if necessary. So let's talk about heat sinks. That's a huge one. So Professor McQueen here proposed that a good portion of the heat was absorbed by the mantle. Other heat sinks are materials like granite, limestone, and water, but we will touch about the mantle in particular. Okay, for me there is some problems. First of all, the temperature and pressure of the water coming from the fountains of the deep, and the whole topic about heat flow, heat engine, and the principle zero of thermodynamics. So the water from the deep, temperature and pressure. Why it's important? Here, all of you can see this graph. It's the three phases of the water: solid, gas, liquid. And this point, this will be important later. So the phase diagram of the water. I would love to know from Professor McQueen at what point of this graph was the water. I think we will be over this point. This point is 218 atmosphere and 647 Kelvin. We are talking about more or less 300 degrees Celsius to give an idea. So where we were, what pressure and what temperature. Here you all can see the integrated formula, the Clausius-Clapeyron equation. This equation is to create this graph. It's not simply lines of paper. Those are actual results of an equation with real data, of course. So that's the critical point. Why it's important? Because when we go over this point, so more than this pressure and this temperature, we will get in the critical phase of water. What the critical phase? Well, the critical phase is when the water became plasma, basically, superheated gas, and that's quite a nasty thing to have around. Let's say that. So I've taken this graph from Answer and Genesis, and here you can see going in the depths of the planets how change the pressure and the temperature. Pressure, you can see the pressure there. To be fair, it's not in atmosphere, but just 1 gigapascal, it's well over the quantity we are looking for. So this quantity is really, really huge. And you can see here the temperature. And here the radius. It's 3-point graph. So where we were, what was the temperature and the pressure of the water. It's really important. Okay, water from the deep. How much water? How much it? So, depending on the temperature, the water from the deep will be transmitted or absorb certain amount of it. We can know that with this formula. Here you can see the energy, mass, specific heat of water at constant pressure, and the change of temperature. We will suppose that the pressure was more or less the same. But yes, we can do the same with constant volume, but of course, under certain circumstances, it's not that easy to do certain calculus. So yeah, that's the formula. And I would love to do some math with Professor McQueen on that. The zero law of thermodynamics, the first one. It's not the first, but the zero law of thermodynamics. Why it's important? Because all system, isolated system, of course, tends to reach an equilibrium, and it's important. Why? Because it always flows from the higher temperature to the cooler one, so it will balance it out. Never the opposite. Here you all can see the Carnot heat machine, an heated material transmitting heat and doing some work in between. Of course, this graph is connected with the second law of thermodynamics. We can talk about that either. Yeah, heat during the flood. Here you can see a slice of the planet, and what we will have the fountains of the deep, and we will maybe talk about the heat transmitted by that water, and also meteorites doing under the assumption of a young Earth. All impacts on the planet were formed more or less during this period, because the whole or almost all of the geological column was produced during that year. So all impacts in it are from the flood. Yes, that would be the most affected area, so the atmosphere, and yeah, with the boat inside it. So most of the heat would be concentrated in that area, and with the people inside it. And yeah, the flow of it into space, we will look into that in a minute or so. But let's be real, most of the it will be concentrated in that area. And a flow from this part to this part will be impossible unless the crust itself was cooler back then. So radiation into space. You can see the formula, and it's quite a simple formula. The important part is temperature is the most important part. More higher is the temperature, higher is the emission of power. Whole is come back to the temperature. More temperature you have, more emission. And to emit enough heat to cool off the Earth, you will need temperature so high to kill basically anything inside the atmosphere. So everyone. Conclusion. I think they are irrelevant because heat flows just to the cooler part to the hotter one, and the mantle is more hot than the crust, so no heat sink there. And the space heat sink is also irrelevant because it's not nearly enough to dissipate that much. I cannot see any model where this flood will be possible, not in such a small time. The heat will be too much and everyone will just die. And the Earth will become just a bowl of molten rock. So it will be awful. And I cannot see any way to have this model, do this model to be true. I cannot see a way right now. So I need to give my thanks to a special person, reason to doubt Jordan, and he was fundamental to this presentation. A good portion of the data used in this presentation was given by him, and I really have to say thanks to him. It was priceless, his help. So thanks for watching. I hope that you enjoyed my presentation, and I can end it there.
Okay, Luca, great timing. With a minute to spare, a minute that we can put into the audience Q&A. So again, I want to remind anybody who's just getting here, we are just in the opening statements. Luca's in the affirmative, so he just ended with his 15-minute opening statement. We're now moving into Professor David McQueen's opening. But we are also going to be having an audience Q&A. So please, if you got a question pertaining to tonight's topic, tag me at Standing for Truth, and I'll save it for a solid audience Q&A. Okay, Professor McQueen, we are going to hand it over to you, my good sir. And whenever you're ready, you got 15 minutes.
Okay, I'm starting my timer to keep track of my time. Thank you for introducing those topics, Luca, because we are going to talk about those. The issue of catastrophic plate tectonics, what I consider minor issue of meteorites, this very important zeroth law of thermodynamics. Now, you'll notice the teaching tool that I've borrowed from a friend of mine. Many of you are aware that my colleague, the engineer in Australia, George Bond, he and I have been talking about blobs and how they relate to this argument. And I thought this would be a good teaching tool. The old hippies that I went to high school with called this thing a lava lamp. So this is a lava lamp. As I go through the algebra and the calculus and the differential equations, if you begin to kind of space out, you can just watch the lava lamp. So here is my first argument, 5 minutes on each argument. Luca, I would suggest to you, my friend, that you're wrong according to algebra. Now, many of you do not want to go with me back to high school physics, or especially those of you that have had to suffer through a couple of years of calculus and differential equations. Well, it turns out that math was my minor, and it's been an interest of mine. Mathematics have been an interest of mine for over 50 years. And so I'm going to argue that the second law of thermodynamics, stated algebraically, shows that many of the points that Luca has brought up are wrong. So let's define some terms, which is also very important. Notice that entropy is, in a lot of books, this Greek symbol here, pi, not like 3.14, but the other one. And it is Q over T. And Q is the temperature or the heat that we're talking about. And T in this equation is temperature. The Q is the amount of heat per unit mass. And so let's look at the algebra associated with the second law of thermodynamics. There are a number of ways to express the second law. We'll use this way here. Heat cannot of itself, and let me move my camera a bit closer here so you can read this. Heat cannot of itself pass from a colder to a hotter body. Now, the of itself part there is an important part of explaining the second law at a high school level. Now, if we go beyond that to actually begin to put some math into this, you'll notice that Luca talked about power as watts being joules per second, and we'll come to that in the next hour and a half. But notice that the Q in these equations, the algebraic statement of the second law, is in calories. E, when we talk about E up here and in the rest of the time, there it is. 1 calorie is, for our purposes, approximately 4 joules. And you'll notice that Luca was talking about several thousand joules. I'll come to that in a rebuttal. But at any rate, a calorie is equal to 4 joules. And so the whole science of thermodynamics developed around the time that heat engines were being developed, steam engines for locomotives and so forth. And a tremendous amount of work went into showing that heat cannot of itself pass from a colder to a hotter body. Now, what that means in our argument is if you have a hot crust, it's going to become colder. Notice that Luca began with commenting about the young earth creationist view of several thousand years. How does that tie in to this overall argument? Well, we will come to these blobs as the next hour and a half goes on. But my challenge at the very beginning is, if denser material is colder, how come you can find in these massive mantle blobs that they are hotter than the surrounding mantle material? If the Earth was really a billion years old, they should have reached this important issue of equilibrium. So that's why Luca is wrong based on algebra. Now let's go to why my newfound friend is wrong on the basis of calculus and this issue that he's already brought up of the Carnot cycle. My argument is that an old Earth evolutionary view, where the idea that we've got an old Earth mantle and old crustal materials, the error that Luca is making is he's actually drawing some Carnot cycles that indicate perpetual motion. My mentor, Dr. Henry Morris, was an engineer, and he loved to point out that the reason that evolutionary use of thermodynamics is wrong is that the second law of thermodynamics breaks actually two laws. It breaks the patent law. In the United States, Luca, you cannot patent a perpetual motion machine. And I'm arguing that you are suggesting a perpetual motion machine in the movement of materials in the mantle. Now, here is the way you would look at this at calculus. This is not exactly the diagram that Luca showed, but it's one that we can talk about as the time goes on. Here's pressure on the y-axis, volume on the bottom. And then notice that in the what's called the Carnot cycle, you're moving from A to B to C to D. And when you do that, you're putting a certain amount of heat into, say, like an automobile engine, and then you're getting a certain amount of heat out. Well, if you work through the calculus of it, the dP, dt, or you look at the differential of heat as a function of temperature, that's always going to involve entropy. There's that phi number that we talked about. Now, this violates the second law, the viewpoint that Luca is presenting, because entropy always increases with time. Now, for those of you that don't appreciate the differential calculus, the change in pressure as a function of time, let me try to make another analogy that would help you to understand the calculus of this. If you talk about my driving in northern Italy, where Luca is from, I would drive a certain number of kilometers per hour. And so that would be a certain amount of distance as a function of time. And so the velocity would be the first derivative of that. In other words, this is dx versus dt, distance versus time, the amount of time to get from the Po River to a city like Milano. So that would be velocity. But if I did it in an Italian sports car, if I did it in a really nice Lamborghini, then I've got the second derivative of distance versus time. In other words, acceleration. I could go from 0 to 60 in 10 seconds. In my Chevrolet that I own, I can go from 0 to 50 in a couple hours. No, I'm just kidding. But you can see what I'm saying. This is what calculus teaches you. It's a differential, first derivative, second derivative, if that helps you to understand what we're saying. Now, in my final 5 minutes here, I'm afraid we have to dig really deep. I'm fairly confident that Luca understands the differential equations and that George Bond does. But let me try to help you to understand what this means. Luca is wrong because of the differential equation talked about in Stacy's book on page 203. And the reference to this book will be in the end notes of this debate. And he's wrong because he's not calculating mantle creep. Now, let's recall what a differential equation like this is. What a differential equation is backwards thinking. You come down and you say, what would the answer be if the Earth was young? What would the answer be if the Earth was as ancient as Luca says it is? So you assume an answer, and then you work back to what the equation would be. And here are the details of it for those of you that remember differential equations. This epsilon dot is the rate of deformation by creep. Now, those of you that have seen me many times in the past know that I enjoy taking from my children's boxes of toys to illustrate things. So here's a couple of boxes that I've taken. Imagine this very cool unit here to be a part of the mantle that is rapidly subducting under the Earth's crust. Another way you can think about it is reverse the two. Let the yellow be the Earth's crust, and you've got this mantle going underneath it. Well, in the physics of this would be referred to as creep. Now, a factor that I don't think that Luca is taking into consideration can be illustrated by this deck of cards. If I take the deck of cards out and imagine this to be the crystals that are in the crystals that are in the magma, I'm suggesting that the evolutionary community are a bunch of jokers. They're not correctly understanding crystal deformation. So at a crystal level, you see how these cards slide this way? This can be thought of as a crystal in either a granitic magma or even a basaltic magma. These are crystals of muscovite, quartz, and so forth that are showing what is called dislocation creep. Now let's continue, go back with the equation here. This rate of deformation by creep, this epsilon dot, is 2a exponent minus u0 kt. Now kt is the same as Luca's been using. That's temperature there. And now let's look at this. This a exponent with the other part here is a mathematical expression of creep. Now U0 is called the activation energy, and KT is something that Luca referred to earlier. This is the thermal energy required to do it. Now, you may recall from differential equations that the hyperbolic sign has to be shown in 3 dimensions, like a hyperbola. But it's beta times the stress KT. Now remember that KT is the thermal energy at a certain temperature. Now, Luca, I hope in the break you can work through this equation and see that if the stress, the sigma, is very small mathematically, then that makes this differential equation what is called insufficient. And the insufficiency of this equation is a mathematical proof of catastrophic plate tectonics. Now, why would that be? We are arguing that the portions of the mantle that were energized by catastrophic plate tectonics, and we can look at this power equation here of watts as joules per second. Many have argued that the creation community has no explanation for the number of joules of energy that are put into things. And as the next hour and a half goes on, as I rebut more formally what he did, you'll see that that's not true. I show me being 15 seconds over. Am I, Donnie?
You look good. You look good. Perfect timing from my end. So, gentlemen, Fantastic job on the timing. I understand even 15 minutes in a debate can fly by. So, again, thank you so much for your opening statements. We're now moving into the 10-minute uninterrupted rebuttal. So, Luca Medugno, we are going to hand it over to you, my good man. And you have 10 minutes for a rebuttal whenever you're ready.
Yes, I want to start strong. We are talking about the second law of thermodynamics. Good. The second law of thermodynamics do not break any law. And entropy is increasing. But what's entropy? Entropy is the amount of work that a system can still do. When you even out the difference from temperature to temperature, the system will not longer be able to do any work anymore. So it's not like I'm saying that entropy is not increasing. We can do any calculus on that. It's not a problem for me. I do love this kind of equation. I want to show the people some of the things that I did back then. Here I have like 3,000 hours of study in these topics. So entropy, it's not a problem. It's a non sequitur. If you have an isolated system, we are not, first of all, so the second law of thermodynamics do not apply right now. Yes, it will become a point where you cannot do any more work, but it's entropy, it's not dispersion of energy. Energy is still there. First law of thermodynamics, the energy of isolated system is always the same. It does not go anywhere. The energy is still the same. I would love to engage with those formulas. I did not understand the point. I really do want to know some of the data, like at what temperature and pressure was the water when it exit the crust. I want to know because that it was be discarded in the atmosphere. Also, the blobs. Those blobs, first of all, what they are or what they were, what temperature they had, what was the thermal conductivity of those things, and what was the area of connection with the crust. Also, even if the crust can transmit the heat to the core, first of all, the core, what temperature was in the core, what temperature was at what temperature those blobs were, what are those blobs, and so on and so forth. I need some answer to respond in a more coherent way. And also we have a problem because most of the meteorites and lava and hot water, we are not even talking about water anymore. We are talking about plasma. Plasma, it's not water. Plasma, it's like the lightsaber. That's plasma. When you have that into the atmosphere, everyone will be cooked, steam cooked, actually. Superheated gas, it's a very nasty thing to have around. So that's a problem. Even if you can transmit all that and you need some data on that, what was the thermal conductivity and things like that. I did work on the Seebeck effect, so I do know a thing or two about these topics. When we have that data, those data, we can speak about it. For my point of view, the presentation of McQueen was off topic because you need to transmit the heat from the crust and the atmosphere, because the most affected part will be the atmosphere. You are dumping a lot of water in plasma form, for what I can understand, into the atmosphere, and that's a problem. Most of the heat will be inside the atmosphere. Then you need to transmit that heat to the crust, and just then to the inner mantle and the core. So those are my points. I would love to discuss more. I leave any time left to this discussion. Johnny?
Okay, Luca, I appreciate it. You've got, let me just check the timer. Okay, that's about 4 minutes. I appreciate that we can throw into the audience Q&A, as we always have a ton of questions that do come in for these important debates. So, Professor McQueen, we are going to hand it over to you. And you now have 10 minutes for your rebuttal as well. The floor is yours.
Okay, I'm going to set my timer here, and let me go to some of the issues that Luca has brought up. Donnie, could you help me by pulling up the first two slides on the geophysics of the blob, please?
Definitely.
So let's see which slide comes up. Yes, we'll start with that. Luca, I hope you can see that this is a cross section going down to the crust mantle boundary. My colleague, George Bond, and I are working more on these branches and the cusp and the blobs, B-L-O-B-S. But when you look at this, next slide, please. Donnie, the next, there we go. Yes. This slide, can you make that full screen, Donnie, or is it already full screen?
No, I can put that full screen.
Yeah, put it at full screen so we can see. Yeah, that's much better there. Now, you'll notice that these blobs, we're going to use my lava lamp here in the next hour. This one is centered over Hawaii. And Luca, one frustration that George and I have run into is the researchers that did this work were from Arizona State University, and they actually did not speculate as to the boundary conditions, exactly what the temperature would be in these. But let's go back to foundational thermodynamics here. We know that the heat is going to go to the cold. And you have already introduced the, go ahead and give me full screen again. I want to go back to that slide, but I want to show Luca this in my critique of what he's saying. So you'll notice I've written down on the back here the most important term, equilibrium. Now, all of us can commonly understand what equilibrium means in the sense of I've lost my balance, I fall over. Well, let's think in terms of kitchen chemistry. You boil a pot of water, it reaches 100 degrees C and boils. Then you put it to one side, and if you walk away under the second law of entropy, that heat energy dissipates. And so it goes from hot to cold. Now, the argument that Luca has presented, revolving around catastrophic plate tectonics, is in part resolved by this blob issue. And Donnie, if you would go back to that second slide of the whole Earth there, I'll make a point from that. Actually, do you have the third slide, the one that shows a lot of red and blue?
This one? I've got about 9 here that.
Well, that's okay. Let's go back to the previous one. Yeah, there. So here's my argument, Luca. If you can make that full screen. You have in catastrophic plate tectonics the crust being subducted. Now, one of the diagrams that you put up for me earlier, I put in my notebook as this phase diagram with pressure and temperature and where you've got liquid water and so forth. And you challenged me to say, well, what's that temperature, McQueen? And what's that pressure that you're dealing with? Well, in your calculations, you show on this particular diagram from creationist sources, you claim, that one of the important temperature points is 8,000 degrees C. And you also comment that if you go through the Q is equal to M times the number of calories and the delta T, you end up with 4,000 joules being put into the Earth's crust. Now, I want you to notice the arrow pointing to the red on that diagram. If you would make it full screen now, Donnie, please.
It should be full screen.
Oh, it is full screen. I'm sorry. I misunderstood. Okay. And so you'll notice the red area there, which is underneath Hawaii. But you'll also notice that there is a blue area. Now, what's the significance of that? The significance of that is that the researchers there at Arizona State University noticed that if these blobs were as old as you claim the Earth to be, not in thousands of years, but rather billions of years, millions of years, they would form a 96-kilometer thick layer. And that is something we don't see, obviously, in the rock record. Now, they found the darker areas to be as much as almost 4% denser than the red areas. Well, the denser material, we know from thermodynamics, you and I both know, is going to be colder. And how come when we look at the modern geophysics, they're actually hotter than the surrounding mineral material? Would they not, in millions of years, Luca, reach a point of equilibrium? And I'm looking on what you presented earlier. Was time part of any of the equations? I think temperature was only part of the equations. And so if you look back at this differential equation that, go ahead and bring it back to me if you would, please, Donnie, full screen. My rebuttal to you, Luca, is if you look at this differential equation and factor in mantle creep, and you've got this increasing deformation by creep, you've got an activation energy and a thermal energy. But look, Luca, there is no time factor here. The time is the entropy, and the time is the enemy to your argument. Because you see, in this differential equation, if you have a very small amount of sigma or stress, then this equation becomes what mathematically is called insufficient to explain. And if you'll notice how liquid this blob is as it moves up, we are arguing that these things are plastic. And in some of the physics that we're going to have to wait a couple of months to come up with, some of the physics that George Bond and I are working on, it could be that as one of these blobs falls, you notice how it falls, it can take heat energy with it. And so this would be a mechanism of the catastrophic plate tectonics. I want to discount for now your comments about meteorites. I don't think that's germane to what we're saying. But your comment about the zero law of thermodynamics is important to comment about. In high school physics, you're taught there's the first law, the conservation of energy. The second, the idea of entropy, things going from good to worse in a mechanical system where heat is being converted to mechanical energy. And then the third law of thermodynamics is often dealt with in physical chemistry. We'll put that to one side. But most people haven't heard about this zeroth law. And it's very important. Let me use my head as the third part. The zeroth law that you talked about is if the yellow box is at one temperature and the blue box is at another temperature, as they interact with my head, they come to a point of equilibrium, of thermal equilibrium. And I think the zeroth law that you brought up, we can just talk about that more after the break, but I think it argues against your position. In other words, the whole idea of looking at the crust mantle boundary now, as geophysics would look at it, would say that you've got this data that show these blobs, but they're not in equilibrium. In a 6,000-year-old Earth, we can explain a disequilibrium situation, but certainly in a billion-year-old Earth, my opponent Luca can simply not explain a equilibrium situation. I show myself as 38 seconds over there, Donnie. Am I close? Can't hear you, Donnie.
Oh, apologies on mute. The good old mute button. Yeah, no, you look good. I paused you for a couple seconds here and there when we were figuring out the pictures. So just on time for the most part. And therefore, that concludes the 10-minute uninterrupted rebuttals. Luca, David, fantastic job so far. Very technical debate. And these kinds of debates need to be engaged like this, you know, in
Luca,
in the detail you both are.
And Luca, I'll comment during the break. I'm going to travel to northern Italy to have you make me some cappuccino. And in lieu of that, I'll go to my
Just
kitchen.
be careful, because if you ask cappuccino in the night, they will kill you.
Oh, really? I see. I don't want. I
Make
think
me
in
one
Italian,
as well. I'm all out, Luca.
In Italian,
Yeah. In Italy, it's a cardinal sin to ask for a cappuccino at the night or
in the middle of the night. Yes.
You can have one just in the morning. If you ask
Okay.
it in the night at dinner, they will get mad at you. I think more in the south of Italy, but
yeah, I think that I can say
it's
capisce. I
literally
understand.
field.
I understand. Go ahead.
All right, gentlemen. Well, we are moving into the 5-minute break now. So David can jump on an airplane, make his way over to Italy, and get his refill.
That's true. And could you drop my video and I'll go get my coffee?
Okay. All right. Here we go. Break time, Luca. If you need to, get up, stretch your legs, go to the washroom, get a drink of water, whatever you got to do, my good man.
I will grab at 2. Why not?
Okay. All right. Well, here we go. We got a 5-minute break, and I am going to first thank everybody in the audience for being here. As I pointed out on Standing for Truth, we do Obviously, we are a biblical creation ministry, but we find it important to engage those of differing beliefs, different worldviews. And in a way, this is kind of how we peer review, some of the research we are doing. Professor McQueen, the team geologist, as well as George Bond. These brothers here have been doing a ton of fantastic research into the heat problem. Luca Medugno is very sophisticated and educated, and he holds to a differing perspective. So why not, get into the ring, jump into the octagon for a sophisticated, unintelligent back and forth on this important topic. So I'm looking forward to the discussion. We've only been through the very technical and also very thorough opening statements, as well as the rebuttals. So we've also got some solid questions flying in. I've seen some people in the chat asking about the endogenous retrovirus handbook. I've got it right behind me here. And so I put out a video this morning with the necessary links. And I see a lot of people placing an order, so that is much appreciated. That's awesome. You can get a full color edition, or you can get the black and white. This one's the black and white. 170 pages, very comprehensive response to endogenous retroviruses. So let's go over a few reminders. We've got a ton of shows coming up. I've just confirmed some debates and interviews as well. We're going to be working on some thumbnails for those and getting those set. But here's a couple that are in store for you guys. I will have these up and good to go sometime tonight, maybe tomorrow. So if you're not yet subscribed, hit that subscribe button so you can get those reminders for all the epic debates coming up. So this one should be interesting. We've got CJ Cox. He'll be back here debating David Preston. Title of this debate: Were the Israelites saved by faith and works under the Old Testament? So this is a new one for me, and this should be fun. This should be interesting for sure. Okay, let's see. We've got a couple more additions to the 2022 Evolution Debate Challenge series. Noah from Fox Official is his YouTube channel. He'll be taking the challenge in June. And Evolution is on trial. Dr. Dino and Fox Official. We've also got Jay Siegert. So he has a creation ministry. He's given many fantastic talks. He's got some important books out on the topic as well. So he's going to be giving a presentation on the 25th of May on evolution. And as we always do, we're going to make sure it's interactive. So make sure you are here for that, bringing forth your questions on the creation versus evolution topic. We also had the 5-month anniversary special for the Evolution Debate Challenge series. Just the other night, we went for about 2.5 hours. I think we're over like 3,000 views right now on that video. That was tons of fun. That was comprehensive as well. And we had a great chat that night with some great engagement from the chat as well. So if you have not yet seen that, please do definitely check it out. And of course, the much anticipated soteriology debate is coming up fast. We scheduled this over 3 months ago, and time flies by these days. So we got Battle of the Roberts, Robert Wilkin, Robert Sungenis, two powerhouses in the world of soteriology. I'm telling you, this is going to be one of the best soteriology related debates you can find. So this is going to be the thesis for the debate is going to focus more on Romans 2:13, but the bigger picture question for the debate is: does the Bible teach salvation is by faith alone, or faith plus works? In the next couple weeks, we got a few more in the Evolution Debate Challenge series coming up. A couple rematches. So Ken Rock's going to be back here, him and Dr. Dino, the sequel. That is next week. Next week, we've also got a new interlocutor, Rune Norderhog. The Evolution Debate Challenge continues, and Dr. Dino and Rune. So that should be fun as well. And just this Friday. So this Friday, we've got, again, James W. Him and Dr. Dino, they debated a month or two ago. And that debate still currently holds the record between 500 and 600 live. That one was a ton of fun. So they have their round two. They've got their round two on Friday. So make sure you are here for that. And we're going to mix it up. First thing in June, we're going to have a show countering the Jehovah's Witnesses. So Kelly Powers, who is well studied, he's an expert on the cults. So we are going to be engaging that topic. Guys, this is just a snapshot of the overall debates, interviews, and events that we do have on the channel. So again, please make sure you are subscribed, hit that like button, and share around this content. And it looks like Professor McQueen has made his way back from Italy. Professor McQueen, I hope you had a good trip. And must have been nice to meet Luca in person. How are we doing, gentlemen?
He and I went down to the Po River and talked about the erosion along the Po River. We'll do that when we visit in a couple of years. I have Mrs. McQueen to thank for my coffee here.
I did not pick up my hat. Give me a moment.
No problem. I have brought in some more of my grandchildren's toys because this issue of equilibrium is an important issue. Where is my hat? I must have my hat also. There we go. Now
also,
we are.
I have my notebook, my letter.
Yes.
So
I must have not got the memo because, unfortunately, I don't have a hat to match up to this swagger.
Yeah.
Top of the line swagger from you, gentlemen.
Okay, very good.
I did not too, but I have one within reach. So.
Okay, gentlemen. Well, let's now move away from the break. I hope you guys are well rested for the discussion. So I'm looking forward to everybody's favorite part of the debate, right? Where the two debaters now get to ask each other questions and discuss the important topic. So Luca, David,
Yes.
David just ended with his rebuttal. And so we're gonna kind of get right into it. Luca will allow you to ask the first question or make the first point. And gentlemen, we got 30 minutes on the clock. So I'll be watching the timer and go ahead. The floor is yours.
Yes. I would love to know more about the expression of the creep. Maybe I do have a problem with the language. I would like to understand what are we calculating, what's the end result with unit of measure, just to give an idea. Because if we are talking about the water, I was asking for a temperature in Kelvin and a pressure. You can give atmosphere, but it's better to work in Pascal. Of course, the metric system is the most simple one for me, at least, that I live in Europe. From that, we can calculate further and give a number in joules, if I recall correctly. So, about your equation, what we are calculating, why it's important.
Okay, let me make a couple of comments. When lava comes to the surface in Hawaii, it's at 2,000 degrees C. I took my suit coat off because here in Louisiana, it's 30 degrees C and burning hot here. That's 90 degrees Fahrenheit for you guys.
Mm-hmm.
So let's use one number in your challenge let me get it in my book here. Let's use the number of 2,000 degrees C. That's where lava certainly comes to the surface. And the pressure, of course, at the surface would be atmospheric pressure. But that's not bearing on what I think our debate should focus on. Our focus should really be at the mantle crust boundary, or at least the asthenosphere crust boundary, as the um, as the excuse me, the two plates are moving through. Now, let me help you. You asked me to define creep better. The movement of a cold, let's say this is the crust uh, in the time of the Great Flood, and the yellow, and then this cold bit of crust under catastrophic plate tectonics is moving underneath it. Now, one thing that I failed to do, and I owe you an apology on this, Luca, is I am a young earth biblical creationist. So I really do believe that there were 8 people on board the ark. After a year of these processes that we're talking about, the 8 people got off the ark, and the human population that we see is a bit more than 4,000 years old. So how can I turn to Luca as my opponent and say, well, it simply cannot be true that there were 4,000 joules of energy being put into the water, because you're quite right. If it was 4,000 joules, it would have evaporated the water, killed everybody on Earth. And so what is a mechanism to counter that? Let me say one more thing, and then you can respond. I want to make sure that I've got my units defined for you here. So let's go back to this. Could I have full screen, Donnie, please? If you're there, that's okay. I'll pull it down this way. So the epsilon dot is the rate of increase of deformation by creep. Now, creep is this factor, A exponent minus, in other words, it's this part here that's parenthetical. That is creep. And then U sub 0 is activation energy. KT is the thermal energy at that temperature. So what my argument is if you plug in the predictions of uniformitarian plate tectonics and catastrophic plate tectonics, because remember, for those of you that don't remember differential equations, you work backwards on differential equations. You assume an answer, and then you see if the equation will fit it. My argument is, the mathematical argument, that this equation, which you can find in Stacy's book, and I really need to show Luca this book because it may be one he would want to reference. This guy Stacy is a professor in Australia, and he wrote this book that I used years ago called Physics of the Earth. Came out in '69, and the fellow's full name is Frank Stacy. And the equations that I've drawn from come from his chapter dealing with the Earth's internal heat and creep. And so what I don't think that you're taking account of as what in the old days would be called thermochemistry, or the thermodynamics of chemistry, is I don't think you're properly dealing with this enormous problem that you can express even by algebra, that unless you've got an adiabatic system in the Carnot cycle, the entropy, the Q over T here, the Q over T, where Q is heat per unit mass, the heat cannot of itself pass from colder to a hotter body. And the point of view that you're defending here, I think, when you take that, if 1 calorie is 4 joules, and you look at this hot crust versus cold crust, this whole bit of research revolving around the blobs that I'm illustrating here throw you into problems. One final comment, and then I'll give it back to you, Luca. I went to my grandchildren's toy chest to illustrate equilibrium. This is a mechanical illustration of equilibrium. So what we're talking about here is disequilibrium in the Earth's surface. So if I begin to take some of these blocks off of this side, it makes this side lighter and throws my system into disequilibrium. So the observation that I, as a geologist, see in the phase diagrams you pointed out in the first hour is a disequilibrium situation. As an old Earth evolutionist, as someone that understands the chemistry, don't you see that if you got millions of years, this system should be in equilibrium, but it's not? Do you see my point, Mia Capisci? You understand?
Yes, I'm writing a little bit.
Okay. As you write, I'll make another point. You challenged me.
Okay.
Okay, I'm sorry. Go ahead. Let me look at yours.
Can you put me in full screen?
Yeah, make it full screen so I can see.
Okay. Can you all read this? Okay.
Yeah, let me read out loud and make sure I can read it. It's energy is equal to
Okay.
the A exponent. That is the equation.
Principle
Okay, I understand.
of thermodynamics.
Yes, right.
In isolated system, it's the du, so the variation of energy, it's 0. So when we are talking about, also, it's correct to say that your formula, it's basically A multiplied per E related to the part of the formula inside the... Yes. Okay. So we can understand each other.
So we can agree that this part is correct.
When we are talking about... Yes. When we are talking about entropy, it's not loss of energy. The energy stays the same. It's constant in a system. When we are talking about degradation of energy, we are talking about a system no longer able to do work. So it's not a problem. We are not working in an adiabatic system at all. And we can agree with that.
Okay.
So my problem...
So we're agreeing that it's not an adiabatic
Yes, of
system.
course it's not.
The Carnot cycle
is not a real...
okay.
It's not a real system. It's useful to find out stuff, formulas, and so on and so forth. It's a theoretical system. It's very good for its purpose, but it's not a real thing. We are talking about reality. Okay.
Well, now be careful. Are you saying that either looking at dq dt as a function of time or dp dt in the Carnot cycle, it is real enough that we can say that you cannot have perpetual motion. You cannot make a machine that produces more output than input. Can we agree on that?
Also, that was a capital T. It's not time, it's temperature. At least the convention is temperature, not time. Time is not...
Oh, yes, that's correct. This is dq dt.
So, but it's not... I will remove my hat. It's not important to my point at all. First of all, we are talking about water. I'm still waiting to know what was the temperature on average, of course, and the pressure of the water that came out on that day. If
Okay.
you have
Okay.
any idea of that,
Okay.
when you have that, my point goes around was what was happening inside the atmosphere. Meteorites and bodies falling to the ground. All the energy was contained inside the atmosphere and the upper crust, so not the boundary below. Also, the water inside it, if it was a certain temperature, and I think we are talking about 1,000 or more degrees Kelvin. We are operating in Kelvin. Do not
Okay.
worry, people inside the chat. It's the same of Celsius, just with 273.15
Right. Right. Well,
degrees.
let me respond to that.
It's just to get to the absolute zero. It's just a technical thing.
You know, you commented early and thanked Jordan for his work about this whole calculation of the joules. You know, Jordan's work, he likes to throw around a number 10 to the 30th joules of
Mhm.
energy through catastrophic plate tectonics, which would vaporize the whole Earth. Where did you come up with the number that you had of 4,000 joules?
I never came up to 4,000 joules. 4,000
Really?
joules, it's a very small amount of power. So it
I
will
must have
be.
misunderstood what you said, but do you think that working through the math that you showed us, that you would really end up with 10 to the 30th joules from a
Mhm.
creationist standpoint of the movement of catastrophic plate tectonics? Or have I misunderstood your point there?
I think you misunderstood the a number given by Jordan, and I did check it up. Was about the nuclear decay. Was about a whole different thing. It was not about catastrophic plate tectonics. I do not put any number inside the catastrophic plate tectonic, and I can also give a reason. I did try to find a figure from creationist, and I never found it.
Well,
I
this is
do not know what are the figures for that event, how much energy was liberated in
you
that
know,
event.
we are
I do speak about meteorites, because if you have the fountains of the deep, you will have ejecta, so you will have things falling down from the sky with heat and energy, a lot of energy, and that's a figure that I gave. Nuclear decay, if accelerated, is also a problem, and I taken those numbers from Jordan. Of course, I check it out
yes.
first. It's not like I just simply
Well,
copied it.
you know, we are an hour and a half into our time here, so I think we need to have another debate in a month, and I will do some
I
work
love
on.
it.
Yeah, well, I'll look up some of these numbers. Like, I don't know the pressure in psi or in kilopascals as the water came up from the fountains of the Great Deep. So I'll do some research on that. But you mentioned ejecta, and as
Mhm.
the lava blew up in the year of the flood, I think we can put a number there of 2,000 degrees C, because that is a realistic number.
Mhm.
Uh, the hottest lava on the earth that we see today is in the Hawaii chain, underneath where we have the blobs coming up in Hawaii. And that lava, when it ejects and then flows, is 2,000 degrees. So we can use 2,000 degrees as a number. But before our next debate, I will try to find some references to the amount of pressure that the water would be under. But Donnie, could you go to the next slide? This slide here. Do you have this one that you could put on the screen?
Yes, let me get the screen up, gentlemen, and just
Go
let me
to
know
that
which
particular slide. Go a little slower so I can see. Keep on going. More. Okay, stop there. Go back one. This will help Luca, I think. You know, this is a teaching tool, this lava lamp here. But make that full screen. Make this image here from 2019 full screen for. There we go. This is seismic tomography. And when I was a university student 40 years ago, this wasn't available. But notice this image of a blob that sits at the base of the mantle. This is below Africa. The slow wave velocity regions are above the blob, and it could indicate the plumes are moving up. Now, my challenge to you, Luca, is if you go to Duncrombie's work there in 2019, and I'll provide you that reference, how come the red and the blue, if this portion of Africa is, this is sub-Saharan Africa, so this is Precambrian rocks that are supposed to be 1 billion years old. How come this is not in thermal equilibrium? What do you think about that?
I can say that we have a good explanation. Inside our planet, it's not like it's just hot. And of course, there is a lot of heat inside the planet, heat and pressure. And we are slowly losing that. In fact, we are alive because of that, because the energy from the sun is not nearly enough to keep us warm. If we can survive during the night, because during the day we are fine, but during the night we need the heat from the planet. So we are losing it, and our planet will be stone cold in some.
Yes.
I don't know. I think billions of years.
That is the evolutionary view. Now,
enough on the topic to have the exact number, but we are losing it. Heat, so the planet will die at some point.
But excuse me, let me ask a question before we go. We're pretty close to the audience question time, are we, Donnie? So let me ask one final question of you, and then we can take some audience questions. I think we're in agreement that in a month from now, we would benefit from another debate. Are we in agreement, Luca? But at any rate, let me ask this question. An argument going back to World War II about entropy and evolution is that if we see in thermodynamics, chemistry, physics, that systems go from more organized to less organized with time, in other words, there is what's called time's arrow of a decrease in available energy. How can you have organic evolution? How can you have the evolution of life over 1 billion years in a thermodynamic system that has the second law arguing against a naturalistic increase in order?
Because it's possible to have an increase in order in an open system, given that the disorder created with the order is more than the order. More or equal, because we tend to forget that the equation of the entropy is
Yeah, I'm going to check it against my charts here.
equal.
You're talking about
or
the
measure
Carnot
to
cycle?
zero. We are forgetting the zero because in the second law of thermodynamics, if you do the calculus, you will find major the Carnot theorem. I cannot remember the English name, but entropy is equal or measure to zero. So zero is still a value that you can get. So entropy is the staying the same in an isolated system or is increasing, but zero is still a possible solution, right?
Okay, we'll have to come back to this when
Yes,
we have our.
it's
I'm sorry. Go ahead.
no. I'm giving you the formula, of course.
Okay.
ds measure or equal to zero.
Okay, let me make him full screen so I can read this. ds is greater than or equal to zero.
Yes.
Yeah, I'll write that down and ponder that. That is an expression of entropy.
Yes.
I don't think
Of
really
course,
applies.
there is the whole
I think Luca,
calculus behind it, but it's quite long. I think it will
it's okay. I think we both
quite over our poor the poor people there. I think
I think we both need to put
torture them further.
We both need to put our mafioso hat on
and
let the audience ask us some
yes,
questions.
with that, why not?
Donnie, give us the first question, please.
Well, gentlemen, let's do this just so the points brought up in the discussion are fresh on the minds of you both. Let's do our 5-minute concluding statements. That way I can organize each question. We'll do about 20 minutes worth of questions after that and wrap it up around the 2-hour mark. So, Luca, you were the affirmative for tonight. I got to say, fantastic job tonight. To the both of you, very easy to moderate. You gave me an easy job. I even had a chance to refill my coffee. You guys were so good. And a very thorough debate on the heat problem, probably the most thorough debate on this specific topic that exists currently. So, Luca, we're going to hand it over to you. 5-minute concluding statement. David, you'll also get 5 minutes, then some audience questions. Luca.
Yes, I have not much to say. I just want to have some data, some numbers, to crunch those numbers and to get to some results. I do love these kind of topics. They are related to my thesis, so I just love the subject. I was working on heat, not heat engines. I was working with the Seebeck effect, so thermoelectricity. So I just love these kind of topics and debates. I can close it here.
Luca, nice hat and nice concluding statement. I appreciate it. And Professor McQueen. Oh, let me just unmute you. Battle of the hats tonight. Professor McQueen, go ahead, brother.
I hope as I get older, look more like Marlon Brando. Was that the guy's name in Godfather?
Oh, yeah, Marlon Brando.
Marlon Brando. I was a bit troubled by Luca during the break. I found the head of a horse in my bed. That's a quote from that movie, but that's a little joke there. So I've got 5 minutes to conclude.
You got it, brother. You got it.
Okay, I'll hit the 5-minute block here. Very complimentary of Luca and the conversation we've had. We need to return to this. On Standing for Truth, we like to find a balance between biblical creationism and scientific creationism. You'll notice that during the first hour, not even I brought up very much about what the Bible has to say, but I want to correct that now by going to the book of Romans and reading a passage for Luca to ponder before we get to the questions and answers from the audience. The book of Romans has some fascinating things in it, and we need to ponder the truth of them. Luke and I both need to worry that our knowledge of mathematics and science don't make us prideful to believe that we cannot be taught. For those of you that are in the audience that might not understand the calculus and the differential equations, I hope you're seeing that two people of opposing points of view can have a discussion. Many of our critics accuse us of not talking about science at all. Well, listen to this passage from Romans chapter 1. In my training, I memorized this 50 years ago, but I won't rely on memory at this time of night. I will read what is called the stages of Gentile world disbelief. Because they knew not God, this is Romans 1:21, they glorified him not as God, neither gave thanks, but they became vain in their reasonings, and their foolish heart was darkened. I fully admit that the fall of Adam and Eve brought sin into the world, and that I myself am a sinner. And so I have to watch about my foolish heart being darkened. Professing themselves to be wise, they became fools, and they exchanged the glory of the incorruptible God for an image made like corruptible man, birds, four-footed beasts, and creeping things. Whereas God also gave them up. Now notice that verse 23. I have thought about this outside of the fiction and comedy of the movie The Godfather, but rather very pointedly as someone that enjoys my time on Standing for Truth with Luca and others, because it allows me to look inwardly as well as argue outwardly. Why would it be that I would even think that evolution could not be harmonized with the Bible? Well, this verse is something I've thought about for 50 years. Professing themselves to be wise, they became fools, that's verse 22, and exchanged the glory of the incorruptible God into the likeness of an image of corruptible man, think of idols, and of birds, four-footed beasts, and creeping things. Standing for Truth has hours and hours of debates and discussions about mankind evolving from everything as silly as strawberries to a very detailed conversation about primate evolution. Is Neanderthal man fully human? That sort of thing. I've got a real concern for my friend Luca and also for other members of the audience that take an evolutionary worldview, that they are making an incorrect exchange. They're making an exchange of the incorruptible God for this idol of evolutionary humanism that points toward birds, four-footed beasts, and creeping things. Thank you, Donnie, for the opportunity to summarize. I think my 5 minutes are up.
Gentlemen, that concludes the concluding statements. Again, I want to thank you both for a very engaging, very respectful, technical, and sophisticated debate. This was a ton of fun. I am going to re-listen to it and as it is so important, and the details that both of you brought to the table are important as well. So, okay, what we usually do, as you both know, David and Luca, you've both been here before. Whoever the question is for, we'll make sure they get the last word. Let's say it's for David. We'll give him roughly 2 minutes. Luca 2 minutes, and then David would get the last word. So here we go. Let me get through some super chats first. Lex, I appreciate the support. You guys are the life and blood of this channel, as I always point out, the reason why we are able to do this full time. So $10 super chat. Lex says, SFT, love the content, proud supporter. Why, thank you so much, and God bless. Much appreciated. Okay. So, and gentlemen, lots of compliments on your hats as well. So next time I'm going to have to match up. Maybe I'll bring a white hat.
We need to put them back on.
Capiche? From now on, go ahead.
Capiche?
Capiche. Capiche. Buongiorno. That's all I know.
Now, do you understand?
From now on, I'm going to make it a requirement. For all debaters on this channel, for the Q&A portion, you got to bring a hat.
Non vedo l'ora. Visto che stiamo parlando in italiano, almeno fatemi parlare italiano.
Italiano.
One day, Luca, you and I will have a full debate in Italian.
Good luck with
I only
that.
know one word, so I'm not going to do very good. Okay, here we go. First question comes in from Cool Jesus. Cool Jesus, I appreciate it. You've always got a good, insightful question. So Cool Jesus has a question for David. David, you get the first question. Well, he says, George, George and David do look a lot alike. But
that's so true. So true.
Okay, here we go. So at what stage of the flood did CPT, for anybody who doesn't understand what that means, catastrophic plate tectonics begin and end? In other words, when in the geologic record do plates slow down to present day speed?
Okay. Let me take my hat off so it doesn't block the light on my whiteboard here. And let me draw a picture. When Luca and I debate again, he'll have to explain to me this whole business of why he thinks meteorites are so important, but we'll save that for next time. So the creation model has the one world continent, with this being the north area here, as a C-shaped continent. The Great Flood lasts in total 12 months and begins over 4,000 years ago in the time of Noah. And so the breakup of this continent into pieces, we've discussed before. In my theory, Eden would be about there, Australia, and to honor Luca, Italy would be in that general position. This would be Australia. This is South America, North America. And so in the first part of the flood, during the catastrophic breaking up of the fountains of the Great Deep, that is when catastrophic plate tectonics begins. And so this area segments and moves, and let me use these toy blocks here as an example. And so the let's let the red be Europe and the blue North America. They break apart. They move back together at rapid rates. And then at a certain point, parts of Europe begin to subduct under North America. I may have said that opposite, but at any rate, that is a catastrophic plate tectonic event that brings up in North America the Appalachian Mountains early on in the flood, and then the Alps are north of where Luca lives. Northern Italy includes part of the Alps, I think, and so they form during catastrophic events midway through the flood. The final part of the question, as I would answer it, is that the end of catastrophic plate tectonics happens hundreds of years after the flood as the Earth is readjusting in its crustal balance. Thank you, Donnie. That would be my argument. I'm curious, Luca, from where you live to the Alps, is it a 5-hour drive?
They are close.
How many hours?
They are pretty close. Milan, it's less than an hour.
Less than an hour. Okay, good.
Driving, of course, from the Alps.
Right.
So
Go ahead, Luca.
that's a good question. I will say. Just think about it. Here you can say
Make
force
that full
equal
screen
to
there so I
mass
can see.
per acceleration. F equals to m per a.
Yes.
So
Mass times acceleration. Yeah.
the people watching, just think about it. Just look at a car, a speeding car, crashing into another speeding car. Then just think about it with a continent. The force is related to the mass. More mass there is, more force there is. Just the Alps, I think that a bang like that would create quite a mess, if you ask me. I cannot see something like that happening, and anything surviving that. It's quite a stretch, if you ask me. If you want to try, just put the mass of a continent, the acceleration or velocity of that, and try to find the force behind it. To find the acceleration, if two continents crash, basically you have the continent from the velocity to zero in basically a second or less. So you can get to the acceleration, and then you can get the force of the impact. Just try it. I think it will be fun to discover the amount of energy released.
I want to give my rebuttal comments back to the audience. So let's take another question.
Okay, yeah. If you want to, your question, Professor McQueen, so you get the last word, but we can move right to the next question if you'd like.
Yeah, let's go ahead.
Okay, here we go. So we've got some good questions that have come in, and I appreciate Luca and David's engagement on these so far. So Pure Aussie Gold, thank you so much for the super chat and the support. This one's for you now, Luca. So he asks, do you visualize fountains like a solar flare? Collapsing volcanoes don't affect the atmosphere much. Could it not be like deep sea geysers we still have filling up from below?
Well, depends on what we are talking about. If we are talking about water coming up with 1,000 degree Kelvin and very high pressure, I think that would be awesome and deadly. I think that Noah would be vaporized by it. But yes, basically a giant lightsaber coming out from the deep. Yep, a lot of it. A very beautiful thing to see if you are at the opposite end of the galaxy, I think.
Luca, appreciate the response. And over to you, Professor McQueen.
If you visualize this as the surface of the ocean in Noah's day, I can't agree with Luca's analogy of a lightsaber, a light sword, that much energy coming out. Again, it comes back to the number of joules of that we're talking about. And there's 1 calorie is 4 joules, and so as I have understood the work really over the last 70 years about the fountains of the great deep, is that there are 2 chemicals, if you will. There is H2O that's coming up. There are literally fountains of water from the subterranean area. And then secondly, lava, which is basically some sort of silicate. And we can, summarize this by H2O and this by SiO4, let's say, the silicon oxygen tetrahedron. And that's some silica-based substance. Luca challenged a few minutes ago about this whole business of 2 plates moving together. Now, we are talking about a movement of continents during the time of the Great Flood, far greater than even the evolutionary estimate of 70 millimeters per year or something like that. During the time of the flood, these plates we are proposing would move at meters per second. And my argument, again, to go back to it, it took me so long to figure out this differential equation that I'm a little bit proud of myself. But I can go back to it again and look at this. If we're talking about the movement of these plates as an increased deformation by creep, and we're seeing this stuff at a elevated temperature, we can explain. Remember, every T in this differential equation is temperature, not time. So time is on the side of catastrophic plate tectonics. And let me find my deck of cards here, whatever I did with it. At any rate, we can use these. The idea of of what on this equation is called, let me find the right board here, what is called deformation by creep at a crystal level, at mineralogical level, is we're actually seeing these pieces like decks of cards moving over each other as they're being subducted. And so I think the correct way to view the thermodynamics is it works in favor of a young Earth, in favor of a movement of plates. Now, one thing that Lucas said that I think we need to return to next time we debate is the issue of no creationist that I know, Baumgartner or anybody, says that when the plates collided, they went from some velocity to zero velocity. The momentum equation, forces equal mass by acceleration, is the difference between me having one of my grandchildren bump into me and me being hit in a soccer game by some guy that weighs 300 pounds. That's the momentum that will kill Professor McQueen. That's not what we're talking about. Even in the flood model, these events are taking place over weeks and months, and in the post-flood time, even centuries. Okay, back to you.
Professor McQueen, appreciate the response. I got to say, before you get the last word, Luca, I'm very impressed with you both on your math, your equations. You are both geniuses when it comes to that. It's making me realize why I like to stick with genetics. So great job on that. Luca, question was for you. So you get the last word. Go ahead.
Yes. First of all, the deceleration part, if was happening during weeks, the continents were much faster than that in your model. But first of all, different equation. It's like that.
Yeah, put
You
it on
can
full
say
screen so I can read it
yes.
here, Donnie. There we go.
It's the heat capacity formula. That's a different differential equation.
Okay.
Heat capacity at constant pressure equals to basically energy. That's enthalpy, variation of enthalpy divided by variation of temperature at constant pressure. That's a different shell equation. And of course, Donny, you can stop. And yes, that's one. A little bit different from yours. And yeah, you are proposing elastic elastic collision
Yes.
because I
Yes.
cannot visualize how elastic collision can create something
And
like
I
disasters.
I usually use a
I would
children's.
love to have some data on that too, like the velocity, the deceleration in your model, and the energy. It will be interesting if the people there are interested in those kind of things. We can maybe do another debate as we
Yes.
were talking.
And see, ordinarily I use a child's modeling clay that's marketed in America called Play-Doh to indicate the Young's modulus and the shear stress. But since you're Italian, we'll switch to pizza dough. What I'm saying is that the consistency of many of these rocks, as you knead the pizza dough and spread it out, um, that is the consistency of the rocks that I'm talking about. Let's go on to Dustin Buck's question. Read it for us, Donnie.
Thank you, Professor McQueen. Thank you, Luca, for your final word. And Dustin, good to see you. Thanks for the question, brother. So he asks a question for, I believe it's for you, Luca, or maybe it's for both. We'll read it together. If the Earth was ever millions of years old and molten, I guess he's trying to say, molten at one time, why do we see uranium or heavy elements on the surface at all? This question is for Luca. So appreciate that, Dustin.
Yes.
Go ahead.
First of all, most of the heavier elements are inside the core. We do have some of those elements, but it's simply a matter of we are on a solid, so it's not like everything went to the center. Something stopped it at the crust, but it's not a liquid that things can float or sink as they like. Most of the heavier elements, anyway, made it to the center of the planet. So yeah, reality is not that simple. That's all.
Thank you, Luca. Over to you, Professor McQueen. I'll get you full screen.
Okay. Ordinarily, when chemists think about a heavy element, they think about uranium 235, uranium 238, thorium, and the whole radioactive decay chain. Luke and I, in our next debate, may want to return to Bob Gentry's work because, as I pointed out in previous debates, Gentry believed that some of the radioactive halos that he saw were indicators of super heavy elements. And this was argued at Oak Ridge National Labs in Tennessee at a very high level with some nuclear physicists that wanted Gentry to pursue this information. And so the idea of super heavy elements is a very important one, I think, because it relates back to creation week in many ways. Well, the question that was brought up is, how can you have any of this uranium at the surface? How can you have a flood year uranium deposit like we find in Australia, in the Western United States? Well, the way that you find that is that these elements were in, and let me make sure you can see this, these elements were in, and I'll use G here for granitic zones within the Earth that were broken by the catastrophic plate tectonics. These granites, in some cases, very early on, were eroded, and in them were minerals like zircon, which is a zirconium silicate, but the crystal structure is big enough that uranium can be in that crystal structure, and so it gets moved to the surface. And I love these blobs moving so much, I'll use them one last time. During this time of catastrophic plate tectonics, you've got magma from the fountains of the Great Deep moving up like this blob that I'm touching here, and it's moving up from the crust mantle boundary, or the mantle crust boundary. It might be encountering other things that are melting up on the surface, but it can bring these radioactive elements from this level up to be exposed at the surface during Noah's flood. Back to you, Donnie.
Professor McQueen, appreciate the response. Luca, question was for you. Go ahead. You get the final word.
Yes. Simply, the density of the planet is consistent with that. We have the denser parts in the core, the crust, and the oceanic crust are less denser, and they have a difference in density. Oceanic crust is less dense than the continents, and then you have water, less denser, and also the atmosphere as the last part. So it's consistent. Of course, you have localized material that are denser, but you need to see the bigger picture. On average, the crust is less dense than the inner layers.
Okay, Luca, thank you. I was just going to point out, Professor McQueen, if I could, we do have one final question, so we made it all the way through. This is going to be good. David, go ahead. I apologize.
Yeah, I was going to say we're at the 2-hour mark, and I have enough strength for one more question. Do you have one more?
Yes. So this is the final question. So we made our way through. Again, great job to the both of you on tonight's debate. This has been a ton of fun. 2 hours has flown by. So this one comes in from Pickled Grammar, and not really specifying anybody. So we'll read it together and figure it out. So he asks, was there lava in the crust before creation? Okay, I think this is for you, Professor McQueen. Or would that be impossible with the water chambers? Why don't we start with you, David?
Okay. Since I was taught the pre-flood hydrology by my former boss, the late Dr. Henry Morris, he never used the word water chambers, but instead he talked about subterranean aquifers and water in that area. And so let's talk about what the Garden of Eden might have looked like. That's a perfect pre-flood time. So in the pre-flood time at creation week, rather, I should say, during creation week, if Adam and Eve were to have dug down and looked at what the land surface would look like, here are the trees in the garden, and Adam and Eve there in the garden. If he were to dig down, what would he have found? Well, the first thing he would have found is there would have been soil from creation. There might have been some sedimentary rocks from the waters flowing off the continent during the third day of creation. That was the first global flood, if you want to think of it in that way. But underneath that, who knows the thickness of this, there would have been perhaps metamorphic and igneous rocks, the lava that the question refers to. But the key is that in none of this would there have been any fossils. So we can put an X above fossils. Why? A fossil is an example of death. This is the creation week. It's when the Garden of Eden was brand new. It's even before the fall of man. And so that first couple, that first man, that first woman, they had access to many things. They had access to gold and other things that they could use. But as they went to streams and looked at rocks, they would have never seen fossils, because fossils are an evidence of death. So, yes, on the idea of lavas, and we will defer what the water might have looked like pre-flood and get away from this idea of chambers of water.
Professor McQueen, appreciate the answer. Luca, over to you for your response.
Yes. Can you put the question up, please? Sorry about that.
No worries. Let me just find it here. Chat is moving pretty quick. So it came in from Pickled Grammar, and I'll just put it back in the chat. And here it is, Luca. So he asks,
okay,
was there... Go ahead.
So sorry. Well, I do not think that's a problem, because if you have water at that temperature, I think that anything else will be molten or even vaporized. So not a problem. You can have lava and water, because it's not water, it's literally plasma. It's a lightsaber. So no worries there.
Well, as we end our presentation, Donnie, I want Luke and I to put our hats back on for a very specific purpose, because I want to tip my hat to my friend and thank him for such a good presentation, and we'll look forward to the next debate. Thank you, Luca.
Thank you to you, Professor McQueen. It was a pleasure, and I tip my hat too. And
I should have done a poll for the chat.
Really,
who rocks the hat better?
Well, it's got to be Marlon.
Though. You both rock.
It's got to be Marlon Brando. I mean, who can argue with that? Good night, my friends. I'm going to leave the chat now by moving my cursor down.
Well, wait a minute, David. Where are you going? That was just the opening statements. I mean, the debate's just starting.
Yeah, 2 hours. That's because you all are.
Yeah, for Luca, it's only about 5 in the morning. So, okay, I'm going to stick around as I usually do for some announcements and reminders. David, Luca, thanks so much for doing this. I appreciate your time. Well deserved and well earned, much earned break. So, David, Luca, we'll see you later.
Teach me in Italian. Arrivederci. What does that mean?
Arrivederci. We will see you. We will see each other again.
Arrivederci.
Arrivederci.
I do know that one too.
Arrivederci.
I learned that one from a specific movie.
We will see each other again.
Luca, I appreciate it. David, he's already gone. I appreciate it. Maybe David was raptured. I'm not too sure. So great debate. I appreciate it. And I'll be back in 1 second. We're going to let Luca out. All right, there we go. There's another one in the books. I think we got to be close to 180 debates now hosted on this channel. So if you are new to this channel, new to the ministry, make sure you check the website. Make sure you check the playlist sections. One playlist titled Debates Hosted by Standing for Truth, and you will find roughly 180 debates to enjoy. If you're a debate addict, that'll keep you busy pretty well forever. Debates on all sorts of topics. And I want to thank everybody in the chat for joining us for tonight's important debate, Honesty Angel. God bless you, sister. Thanks, SFT, Professor McQueen, and Luca. God bless all. God bless you as well. Luca, definitely. Please share this around. Very technical debate. And I really enjoyed it. I see some people in the chat talking eschatology as well. We have hosted some debates on eschatology. I think our most viewed debate actually is an eschatology related debate between Kent Hovind and Stacy Turbeville on preterism versus post-tribulation rapture. That one has a ton of views. That one was a ton of fun. So if you're into that specific topic, eschatology, check that out. We've got other debates on the channel as well. So I did want to go over a couple reminders, though. We are going to be back here this Friday. The Evolution Debate Challenge series continues. Dr. Dino, James W. This debate challenge series in 2022 has been a blast. We've done a ton of them, almost, it seems, one a week at least. We've got a playlist. I've got them up on the website for the most part. We're close to 30. We're close to 30, including the ones that myself, Professor McQueen, and Ramat have done as well in terms of that series. So if you're someone of an opposing view, but you're interested in a professional debate, a respectful debate, please let me know, and we can set that up. Sam? Good question. Yeah, if you look at the debates hosted section on the channel, we have done several of those very interesting ones. A couple that come to mind, like I said, Stacy Turbeville and Kent Hovind. If you haven't seen that one, please check it out. That's one of my personal favorite debates on end times. And then we had one between Kent again and CJ Cox, both seasoned debaters. That was specifically on pre-trib versus post-trib. I've had a few informal debates on that topic, not formal, but informal debates that I thought were a lot of fun that should be on the channel as well in the various playlist sections. So I'm just going to screen share here real quick as we wind it down and just let everybody know. If you go to the website, as I have a lot of questions coming through, and if you have not yet checked out the Endogenous Retrovirus Handbook on Amazon or the website, what are you waiting for? This book is the most comprehensive response to endogenous retroviruses that you're going to find. And, I promise you, it's worth it. So click the link, go to the website. It'll take you right to where you can order it, and they'll have it delivered to you in a day or two max. And if you have any questions or anything like that, feel free to email me. Anything that you want to clarify in terms of this book. It'll be worth it. So click that link, order yourself a copy. Benjamin, who has done a lot of the designs for our other books, for example, the Independent Origins Handbook, which you can get as well. The heterozygous Adam and Eve picture, the famous picture. You can order those all from the website or our Goodreads page. If you haven't been on our official website, definitely check it out. Endless content for you. It links our channels. You can go to the Creationist Clothing website. Right on the home page, we've got a ton of fascinating lectures for you. Neanderthals, Human Evolution with Dr. Jerry Bergman, Michael J. Ord, who's been on the channel 7 times, I believe it is. Whatever happened to the woolly mammoth. We get into some theology, soteriology as well. We recently had Anthony Rogers here to discuss the nature of God and the Trinity, oneness, for example. Here's some interesting debates as well that we've hosted right on the main page for you. And you can also check right to the side. We make it nice and accessible, answering common questions, refuting arguments, tons of questions. You can just click right on the screen, right on the main page, and it'll take you to the appropriate destination. If you do go to the video section, event section, article section, resources section, there is unlimited content. Also, we are doing this full time. We put out full-time content. We're writing books full-time. I think as a ministry, we've now put out roughly 15 published books, with a few more we are working on. So if you'd like to support us, you can donate to us right through the website, or you can become a patron. So where you'll find even more exclusive content. So let's check the chat real quick. Ashley Myers, good to see you, sister. I appreciate you supporting the ministry and buying the Endogenous Retrovirus Handbook. I hope you enjoy it. And yeah, definitely, if you're just joining us and you missed the live show of this debate, this was a debate to remember. Very technical. But both Luca and David McQueen, they put a ton of work into this debate, into this topic. It was pretty heavy duty. So we do also like to host debates on very hyper specific topics like this, especially these more challenging topics. This was the heat problem. Last month, I specifically did a debate with Snake Was Right on endogenous retroviruses, and we are planning on more of these kinds of debates in the future as well. I will say, for the Evolution Debate Challenge series, we have a ton of debates coming up, but Kent and I spoke recently and discussed how we can move forward and kind of change things up now that we have done close to 30 of these in the last 5 months. So if there's any evolutionists out there who want to debate really specific topics, so what we're thinking is, instead of the typical, is there reasonable evidence for evolution? Kent and I would love to do some really focused debates as well. Pick your one favorite line of evidence. Let's say if it's ERVs or vestigial organs or nested hierarchies, you name it, whatever your favorite topic is. We want to do an entire debate on just that. So we would have, you and Dr. Dino, whoever the evolutionist is, those willing, choose your favorite topic. You can start. Right? Take 10 minutes, 5 minutes, whatever you need to present your case regarding that one specific line of evidence. And then we'll just, we'll debate that for an hour to an hour and a half, rather than the multiple topics. But, that's for anybody who's interested. We're always willing and looking for ways to change it up, keep it fun, keep it new for you guys. So, Luca says, I have the shirt. ERVs is more than fine. Yeah, so that would be interesting as well. Luca and I have had a fantastic debate in the past where we did touch on that. So, and I think that's pretty much it. I think I'm going to wrap it up here. I put out a video this morning as well that goes into about 20 minutes worth of detail in terms of the ERV handbook. So if you have not yet seen that, please check it out. And in the description box of that video are all the relevant links, the links to the full color edition and a link to the black and white edition as well. So I think that's pretty well it. Again, if you're interested in a debate on this channel, as you know, we keep them professional, formal, even if you are somebody who disagrees with some of the positions of myself or those associated with this channel, from experience, 180 debates we've hosted now. We keep it professional. We keep it as equally timed as possible and respectful, as Luca and David both demonstrated tonight. So Luca, David, great job. This debate was awesome. I'm definitely going to be re-listening to it tonight. So again, to the debaters, thanks so much for your time. If it wasn't for the time and the generosity that the debaters give us, we wouldn't have so many awesome debates for everybody. So that's why we want to treat the debaters, the interlocutors that give us their time for these shows, with the utmost of respect. So again, thank you for doing this. And that's pretty well it, guys. That's all that comes to mind. So we'll see you on Friday. I think we're going to take tomorrow off, as we've been putting out content nearly every single day. So we'll let you guys enjoy that which has been put out for you guys over the last week. And we'll see you again on Friday for the epic rematch, Chapter 2, James W. and Kent Hovind. God bless everybody. Standing for Truth is out.